Hello viewers, welcome to Elibu TV, a place where you watch and learn. I am your tutor, Alex Musawa, and I'll be taking you through Physics Form 4, lesson number 36. Our title is Radioactivity and Radiation Detection. Our objectives are to identify various radiation detectors and their differences. Number 2, to identify the various instances radiation detectors are used. We have various radiation detectors because you can come to a place whereby you see such a sign. That means the area is there is radiation around that area, and this is a warning sign to tell you that you should not cross that place without having some kind of protection. Therefore, radiation can be detected. Since you cannot see with your naked eyes radiation, there are some instruments and there are some instruments that we use to detect radiation. First, we can use photographic emulsions. As you can see from that photo looks like it is burnt. It's a photo, but it looks like it has been burnt because it has been exposed to some kind of radiation. All the three radiations affect photographic emulsion or plate. Photographic films are very useful to workers who handle radioactive materials. The workers are given special badges which contain a piece of an exposed photographic film. For example, if you work in a factory where there's a lot of radiation, you have a badge which has a photographic film that has not been exposed to radiation. If during the time it has been worn, the worker was exposed to radiation, so when the worker gets exposed to radiation, the photographic film darkens, implying that further precautions should be taken. Next, we have a cloud chamber, and the first cloud chamber we look is the diffusion cloud chamber. The common diffusion cloud chamber is made up of a cylindrical transparent container. It is partitioned into two compartments by a blackened metal plate. The upper compartment is fitted with a transparent perspex lid, and its top is lined with a thin strip of filtering soaked in alcohol or water. The bottom compartment is fitted with a sponge and closed with removable cover. The upper compartment contains air, which is at the room temperature at the top. The air at the bottom is at a temperature of negative 78 degrees due to the layer of dry ice placed in the lower compartment. At a certain height above the base of the chamber, the air contains a layer of saturated alcohol vapor. Here, the alcohol droplets form on the air ions produced by the radiation. These are seen as tracks along a path of radiation. Next, we have the expansion cloud chamber. When a radioactive element emits radiations into the chamber, the air inside is ionized. If the piston is now moved down suddenly, air in the chamber will expand and cooling occurs, as you can see from the diagram. When this happens, the ions formed act as nuclei on which the saturated alcohol or water vapor condenses, forming tracks. Next, we have alpha particles. And what are the properties of alpha particles? They are short, they are straight, and they are thick. Next, we have the beta particles. As you can see, the beta particles, they are thin, they are irregular in direction, they are lighter, and they are faster. Next, we have the gamma rays. They are very scanty, as you can see from the diagram, and they are jointed. And we have a Geiger-Muller tube. It is a type of ionization chamber. As you can see, it is used to detect radiation. As you can see from the diagram, it has a mica window, it has a particle path, it has the anode and the cathode. And that is the end of our lesson. Number 1 question. Describe how a Geiger-Muller tube works. Number 2. Name 4 sources of background radiation. Number 3. What is artificial radioactivity? For more, our reference comes from KLB Book 4, 5th edition, 2019. And for more information, contact us on our phone number, on YouTube, Elimu TV, on Facebook, Elimu TV, and on Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.